Hi, I'm Nathan Hode, and I make an adventure game about our cat, Coco. In the last video, I talked about using the finite state machine pattern for NPC behavior in my game, and after uploading that and sharing it around, I got a bunch of questions asking for a more detailed explanation of how it actually all fits together. So hopefully I'm going to cover some of that in this video. Now first up, this is not a tutorial. I'm not really going to teach you how to do this in your game. I'm just going to explain how it works in my game in more detail, and hopefully you can build on that for whatever you need. So let's have a look. Okay, let's have a look at the state machine working at the moment. So we have a scene here with Coco, and there's some skeletons up ahead. Let's turn debug on so we can see their path. So you can see I'm in their field of vision here, but this tree should just block me from view. Oh, now they can see me. So once they've seen me, they'll start some basic pathfinding around to chase me around. Once they get to the end and they don't know where I am, they'll look around. If they don't see me in that time, they'll go back to patrolling and pathfind back to their patrol route and just keep going like nothing was happening. So you can see there I'm in their field of vision again, but the cliff is blocking their view. So they just keep patrolling like they haven't seen me. Okay, so now let's have a look how this actually works. So the reason you would use a finite state machine for enemy behavior is to simplify and break apart all the specific scripts for any given behavior. So the ones you saw before were mainly patrolling and chasing. So only one of these is ever active at once, and that's governed by the state machine itself. So this state machine, or the way I've implemented it, is loosely based on the GD script example, which I'll link to in the description. And there's a bit of inspiration as well from the DevDuck one, which I'll link to as well. So a point I'll make here is that each state is encapsulated and declares any dependencies it needs for information. So the body here is the kinematic body that is its parent. Facing is just a position 2D that works out where the field of vision is rotated to. Player detection is within that does that smart like raycast to work out if the player is behind something. And animation controller is something that governs the animation tree, and based on which way the character is facing, it will work out the blend tree for the animations. Okay, so let's have a look inside patrolling. And you can see here it's exporting stuff it needs. And so when we do an update tick, it will, so if it isn't currently on the path, it will find a way back to the path and then just like pathfind its way back. Once it's there, it will then not be returning to the path and then do its usual thing of finding the next point to move to. It will move there, and when it gets to the end, it'll just turn around and repeat that process. And now if our player detection has seen the player, we will emit a signal. So it's important that states don't refer to other states. Otherwise we end up with this massive spaghettiness of hard to follow what is doing what. So it's important here that we emit this. So then the body is then, so the body will then pick up on all these signals. So when we saw player, we'll transition to surprise, which will then go to chasing. And then we begin the chase. So in our chasing state, it again declares what it needs. And then on our tick here, we'll do a quick check if we're looking around, so ignore that for now. We do a pathfind to try and find where we last saw the player. If we're at the end of the path, we then do our look around thing, so it's just running on a timer just to look around in a few different directions before giving up. So there's a little bit of magic here when two skeletons collide. So this soft collider originally was based on the Heartbeast one from the action RPG series that everyone who's ever done Godot seems to have started with, and it's a great tutorial series. I'll link to that in the description. This one in particular is actually augmented a little bit based on something I saw from Game Endeavor, which I'll link to as well in the description. So long story short, it fires a whole bunch of rays around it to work out whether it's colliding with a sibling, like two skeletons hitting each other. And what it will do is, based on where the player is, it will do a dot product from that line to work out which ray is the best one to go in but offsetting that by any ray that's colliding with a sibling, if that makes sense. So like, if the player is over here, you have a skeleton here, and this skeleton's trying to get through, these rays will be colliding, but the best fit might be up here, so that way it will go around this way until finally it can get through to the player. Okay, so, and then our animation controller just applies the direction for the animation. And then once we've looked around a few times, we emit the lost side of play, and again it's important states don't refer to other states. So then back up in our sword skeleton, we've lost sight of player, goes back to patrolling. So that's pretty straightforward. So one of the main reasons I say that states should declare all of their own dependencies and not refer to other states is it means that they're shareable between things. So then this patrolling state I can actually reuse for a town NPC. So let's have a look at an example of that. Okay, first up, let's turn debug on. So you can see here's a little me walking around, and there's my path I'm following. So that's the exact same state that the skeletons were using, with just different dependencies slotted in for a slightly different use case. So let's just have a look at that. Okay, so here we are inside that NPC, and we can see the same state machine and state set up here. So this is the same patrolling script. We set up our body, our facing, player detection. So the player detection in this case just means they stop walking if Coco is standing in front of them. That's pretty much the same thing. So what's different here is we have another talking state, which I'll talk through now. So inside our talking state is really quite simple. So it just kicks off the dialogue manager, and when the dialogue is finished, we emit this finished talking signal, which is picked up by the body again. And so when it's finished talking, it just goes back to patrolling. So it's all really simple once you get a few things hooked up. So another question I got was how the pathfinding actually works, so before doing this I had no idea either, and then I looked up a couple of things in the docs, and it's actually really easy to do. So you just get this navigation 2D, which as you can see here I've just defined all over the place, and my trick, I think a few people had their things still being snagged on colliders, so everything is in a little bit from the collider so that it still has a chance to wrap around. I also have a little bit of like friction and deceleration as it changes directions, which I think helps stuff just get around a corner. But yeah, so you can see everywhere they can pathfind is all just defined, and then so the skeletons themselves are then told about this navigation 2D, which then they use for the pathfinding, which we saw before. So there's not actually a whole lot to the navigation stuff. Godot does all of the complicated stuff, and I've heard in Godot 4 we're going to be able to navigate around moving things, because at the moment we're kind of stuck with a static navigation area, which is why I had to do the skeleton navigating around each other thing. But hopefully in Godot 4 we can then not need that, which will simplify things. But for now this works quite well. So I think that pretty much wraps everything up for this video. If you have any more questions or want anything in more detail, then just ask and I'll try and get to it in a later video. But for now, I'll see you next time.